Morning, everyone. Is my voice clear? Okay, Veena. So I think my voice is clear. Okay. So today we are going to start the chapter Unit and Dimension. There are a lot of basic things and very useful chapter. Two or three or sometimes more than three questions may be asked from this chapter only. So let's start our topic. What are the various topics that we have to study in this chapter? The it is mentioned over here. Okay. So starting with the first thing, that is what is SI system or what are the fundamental units in SI system. I think you everyone knows these units: length, mass, time, current, temperature, amount of substance, and luminous intensity. These are the seven fundamental units. Very good, Sujan. These are the seven fundamental units. Now, the term which is most important, there are two supplementary units as well, that is plane angle and solid angle. The unit of everything is mentioned over this slide only. So we don't need to take a lot of time over it. I think you everyone knows that. Now, after this supplementary units, there are some derived units. Derived units are something which can be derived using these fundamental units. For example, if I say, this is general basic thing. If I say, find the unit of speed, this is very fundamental thing. Speed is equals to what? Distance over time. Distance is the length which has a unit meter. Time is a fundamental unit which has a unit second. So it will become meter per second. That means derived unit are the units which can be derived using fundamental units. That's a simple thing. Now, moving further, what are dimensions? Dimensions, listen to me one more thing, one more time. For example, if I talk about acceleration, you know that acceleration is equals to change in velocity over time period. So change in velocity has a unit meter per second and time is again second. So its unit is meter per second square. So dimensions are what? Dimensions are the powers to which a fundamental quantity are raised to represent that quantity. That means if I talk about acceleration, it has a unit meter per second square. That means meter has a power 1 and second has a power minus 2. So these 1 and minus 2 are the dimensions. These 1 and minus 2 are the dimensions of acceleration. 1 dimension in mass, minus 2 dimension in second. So dimensions are the powers to which a fundamental quantity or fundamental unit is raised. I think definition thing is clear. Similarly, you can achieve dimension for any of the physical quantity. So dimension definition is clear. After that, you can write dimension of. Now the thing is how to represent these dimensions. Now to represent these dimensions, mass can be represented by M, length is represented by L with the bracket. This is this representation of quantities. Time is represented by T. These are these three very basic units or three very basic dimensions. The power to them will be the dimension. These are just the representation. MLT are just the representation of mass, length, and very fundamental thing. What is the use of dimension? Use of dimension, the first use on your screen, I am going a very quick speed for this topic. Just tell me one thing. Can you find the dimension of capital G? Can you find the dimension of capital G? What is capital G? Universal gravitational constant. Can you find the dimension of capital G? If you know how to find, only then I will move further. For example, you know the relation F is equals to G M1 M2 over R square. I am asking you find the dimension of this capital G. Let me check if you are aware with this thing or not. Find the dimension of this capital G. So first thing that you should do, make the formula in terms of capital G. So G will be something F R square by M1 M2, where F is the force. And you should remember few of the very fundamental dimension like force. Force has a dimension of MLT minus 2. MLT minus 2. This is the dimension of force. R is the distance, which is a power dimension of L, but it is squared, so it is L square. Over mass. Mass has a dimension M. So there are two masses, that is M square. Now you can write it as, if you solve this out, M square will go upward, that is M minus 1 L cube T minus 2. This is the dimension of G. This is the dimension of G. I think this is the basic thing that you should know. I am just revising the things so that there is a clarity in your thoughts. Moving further. Tell me whether you know that or not. It will be beneficial for me as well that if you know these things. Establishing relation. Now someone has replied, yes, sir. Everyone knows that. I think Logesh is saying yes. Okay. Establishing relation among physical quantities. Now, this is a one very basic or very good use of the dimensions. What it says, I will give you an example only. It is mentioned that the time period of a simple pendulum depends on two physical quantities, L and G. It is mentioned. Then what is the exact relation between them? That is asked. The question says the time period of a simple pendulum depends on length of the simple pendulum and the acceleration due to gravity. So we don't know the exact relation. Then what we will do? We will let that time period is proportional to L and G, and L raised to the power A, G raised to the power B, that we have assumed. Now, next thing is write the dimension on each side. If I write the dimension of time, that is T, this is a proportionality constant. There will be some constant after that. So L has a dimension of length, that is L raised to the power A. Acceleration due to gravity has a dimension LT minus 2 to the power B. Now compare the powers on both the sides. Compare the powers on both the sides. If I compare that, L has a power A and L has a power B. So total power of L is A plus B on the right side. But on the left side, L is not present. That means L has a power 0. So first equation is A plus B equals to 0. If I talk about T, T has a dimension, or you can say minus 2B. Minus 2 here over B. So minus 2B. In the LHS, T has a power 1. So B is equals to minus 1 by 2. That's what we get. If we get B, then you can easily calculate A. So A will be 1 by 2. I think you can see that. Now, after calculating A and B, you need to place these values in the equation. So what is the time period? Time period is proportional to L raised to the power A, that is 1 by 2, into G raised to the power B, that is minus 1 by 2. So T is proportional to, you can write that 1 by 2 is the under root L over G. Now there is a proportionality constant. The value of this proportionality constant we cannot determine using dimensional method. So this is the one of the drawbacks of the dimensional method, that you cannot determine the constants using this dimensional method. So T is proportional to root L over G. I think everyone should remember that, or everyone remembers that T is equals to 2 pi root L over G is the correct answer. So the procedure should be very much clear to you whenever there is a relation. Now, the key point is the relation among the physical quantity must be of product type. If this relation is of addition or subtraction type, then it's not possible to establish the relation among them. So one thing to be clear, that relation among the quantities should be of product type, not of addition or subtraction type. Clear? Next thing, we cannot determine the constant, that is 2 pi here. We cannot determine these constants. So this is the one of the use of dimensions to establish the relation among quantities. Now the second is to check the correctness of a question. This is again a very important topic. Lot of questions were asked from it. So don't take it lightly. To check the correctness of a question, one thing, for example, I will take a very simple example. Let's take, there is a equation. Everybody knows the equation. S is equals to ut plus half a t square. Now, the basic principle about this use of the dimension method is that you can add or subtract only the similar physical quantity. Listen to me again. You can add or subtract only similar kind of physical quantities, like you can add distance with distance. You cannot add distance with time. You cannot add time with mass. You can add time with time only. That means subtraction and addition of same physical quantity is possible. This is the very basic fundamental rule, and this principle is known as principle of homogeneity. Principle of homogeneity. What it says, that same type of physical quantities can be added or subtracted. Is it clear? Force can be added to force only. In the same way, what does it signify? It signifies that there are three terms here: 1, 2, and 3. So all these three terms must have the same unit or same dimension. Again, listen to me. The number of terms in the equation, all terms will have or must have same dimension. That means if this term is distance has a dimension of L, then all these terms must have the dimension of length. For example, you can clearly see that u is the velocity, which is Lt minus 1. T is the time, which is t. So you can see that the dimension of t will t cancel. So L is here. Here you can say A is the dimension of Lt minus 2. T is t square. Again, it will be cancelled. So dimension is L. So all three terms will have same dimension. If it is, then the equation is correct. Then the equation is correct. So what is the use of this? How the question can be formed using this property? So let's check a question. Question says, the equation is mentioned, F is equals to A T. Clear? Where T is the time, A is a quantity. So question says, find dimension of A. Find dimension of A. Answer quickly. Answer quickly. F is the force, T is the time, A is some physical quantity. So find the dimension of A. Can anyone find that? MLT minus 3. Veena is saying MLT minus 3. Okay. Let's check it. What we have learned that both the terms of the equation, yeah, or you can say all the terms of the equation must have same dimension. Here the term is f. So f has a dimension MLT minus 2. So this AT should also have the same dimension. We don't know the dimension of A, mentioned it as A, and the dimension of T, we know that that is T. So dimension of A will become, this T will be transferred here. So that is very good, Veena. That is ML T minus 3. Very good. This T will be transferred here. It will become minus 3. This is the easiest way or simplest meaning of this use. Now there can be a lot of questions can be formed. Moving further. Now there are some punchlines. Some punchline says angles have no dimension. For example, if I have written sine something as omega t, then angle is what? Omega t is the angle. So this angle will have no dimension. Is this point clear? Next is power of exponent is dimensionless. Power of exponent something like something it is mentioned as, for example, it is mentioned as e raised to the power 3a t square. So what is the power of this exponent? Power of this exponent is something 3a t square. So this whole term will have no dimension. So this whole term will have no dimension. Clear? That means this term is dimensionless. And these are the two punchlines from which the questions are asked. Like, for example, they will give you a question like something, they will tell you sine kx. They will give you this term and says that x is the length. Then find the dimension of k. X is the length, then find the dimension of k. So what we have seen that, or we have learned that the angle total has no dimension. That means dimension of kx is 0. Okay, Chichuni says dimensionless. Now listen to me very carefully now. This is a very fundamental thing. Listen. The kx will have no dimension. Clear? The angle have no dimension. That means k into x has no dimension. But they are asking the dimension of k only. Find dimension of k. So if I talk about dimension of k, so dimension of k will be 1 over dimension of x. Can you see that? X can be transferred here. Or you can say it is dimensionless, that is m0, l0, t0. This is dimensionless. So this is can be written as m0, l0, t0 divided by dimension of x. And dimension of x is what? L. Dimension of x is what? L. So if I take L upward, it will become L minus 1. It will become L minus 1. Are you getting this point? The whole term kx has no dimension, but k will have the dimension. So you can clearly solve it here. There is no need to do like this. What you can do, we don't know the dimension of k, but we know the dimension of x, that is L. But the product should be 0. There should be no power. So the k should have dimension 1 by L and L. So it will become dimensionless. Dimensionless. So k has a dimension of L minus 1. You can clearly see that. So for after these punchlines, we will solve some questions. This is a very basic question. E and G denote energy and gravitational constant. Now let me ask you one thing. Remember few of the dimensions like velocity, acceleration, force, energy, work done, torque, gravitational constant, and you will say these are the very basic fundamental dimensions that are used generally. Momentum, impulse. Write these dimensions and remember them. Write these dimensions and remember at least few of them. So the question says E and G represents energy and gravitational constant. Then E upon G has the dimension of E upon G. E has a dimension ml square T minus 2. Clear? And the dimension of G we have calculated as m minus 1 L cube T minus 2. I think that was the correct. That's what we have calculated. So now you can check that after solving, it will become m square L minus 1 and T will become 0. M square L minus 1 T 0. Very good. That is B. M square L minus 1 T 0. That is option number what? B. This is the very fundamental question. This question was asked in the NEET examination. You don't believe that. This is again a fundamental thing we should remember, the dimension of RC. So first thing that you should remember, RC is called as time constant. You don't need to calculate this dimension separately, that you are finding the dimension of R, you are finding the dimension of C and then putting together. RC is known as time constant. In which chapter we have seen that it is the charging of capacitor, which is a topic, not the topic I think in your NEET examination, but charging of a capacitor is the topic in which this term is used, and it is called as time constant. If it is time, then its unit will be of time. Its unit will be of time. So remember this. This is frequently asked question. FAQs. Moving further. This is again another variation. What is it? If force, acceleration, and time are chosen as the fundamental physical quantities, find the dimension of energy. Find the dimension of energy. In such type of question, what you need to do, this is the question based on first application of dimension. Like they are saying energy depends upon these physical quantity, force, acceleration, and time. We can take any power of them. Let's suppose this is A, this is B, this is C. Clear? Now write the dimensions of every physical quantity. So if I write as energy has a dimension ml square T minus 2. Force has a dimension of m L T minus 2 raised to the power A. Acceleration has a dimension L T minus 2 raised to the power B. And T time has a dimension T raised to the power C. Now compare the powers on both the sides. If I compare the power of m in RHS has power of m as A only, m raised to the power A. And here is 1. So A is equals to 1. That's what we got very quickly. Moving further. Now comparing the power of L. In this term, L has a power A, L has a power B, and there is no L. That means A plus B, L has a power A, L has a power B. Here, L has a power 2. Clear? So B is also going to be 1 because A is 1, so B is also 1. Okay. Next, comparing the power of T. T has a power minus 2A. In this term, minus 2B. In this term, plus C is equals to minus 2. Here the power of T is minus 2. A is 1, minus 2 will be cancelled. So C has a value of 2B. That means 2. Now, after knowing the value of these three quantities, we can place these quantities in this equation. And if I place there, it will become energy has a dimension F raised to the power 1, A raised to the power 1, and T raised to the power 2. So which is correct option? Which is correct option A, B, C, D? Very good. C is the correct answer. I think this point is clear till now. How we solve these questions. One more question there is. The question says the time dependence of a physical quantity P is given as P is equals to P naught E raised to the power. This is not T2, this is T square. E raised to the power minus AT square, where A is a constant and T is time. The constant A, now they are talking about the dimension of A. So first of all, write it as P is equals to P naught E raised to the power minus AT square. They are asking me the dimension of A. Clear? Now, what we have seen that exponential, the power of exponential has no dimension. That means this complete quantity AT square has no dimension. If this complete term has no dimension, then what should be the dimension of A? Can anyone answer? T square has a dimension T square. Then what should be the dimension of A so that it will become dimensionless? It become dimensionless. B. Very good. This is T square. So if it is T minus 2, it will be cancelled out and it will become dimensionless quantity. So A has the dimension of T minus 2. T minus 2. I think this point is also clear. Moving further. Significant figures. Okay. How many of you know the calculation of significant figures? How to calculate significant figures? Do you know that? Or should I describe it in little bit of detail? Not that much, but little bit of detail. This is a decimal. Okay, listen to me. First of all, I will define few of the terms. In this calculation of significant figure, one thing is more important. The important thing is zero. Zeros have very important role in the calculation of significant figures. So I will define zeros first. You can clearly see that these zeros are called as leading zeros. Now listen to me very carefully. Leading zeros. Why leading zeros? Because they are before any number starts. The number actually starts from 1. These zeros are leading zeros. And you can see that these zeros are trailing zeros. Trailing zeros. Now there are two more zeros. One is this, one is this. These are trapped zeros. They are trapped. You know the meaning of trapped? You know the meaning of trapped, I think. Trapped means the zeros which are between two numbers. Clearly, I think this point is clear till now. Now the punchline, the rules starts. So there are not so many rules. First rule is very clear, and it states all. Can you see that this 1, 2, 5, 6, and 1? These are the non-zero digits. These are the non-zero digits. So first statement is all non-zero digits are significant. First statement is clear. Whenever you see non-zero digits, that means 1, 2, 5, 7, whatever it is significant. Now let's talk about zeros. Now let's talk about zeros. We have learned three types of zeros there. So first statement is leading zeros are non-significant. Is my handwriting, can you understand my handwriting here? I am writing very quickly actually. So the statement is leading zeros are non-significant. Okay. So leading zeros are non-significant. First thing is clear. That means in this number, you can see that these are the leading zeros, and these leading zeros are always non-significant. They will not be counted. Next is trapped zeros. Trapped zeros. They are always significant. Always significant. Remember these lines. 2 points are clear. Leading zeros, non-significant. Trapped zeros, significant. Now the remaining term is, which is very important, the remaining term is trailing zeros. Trailing zeros. Now the thing is, first thing is, trailing zeros are non-significant. NS means non-significant. If decimal is not present. Decimal is not present. For example, if the term is mentioned as 4,000, clear? Now these three zeros are trailing zeros, and in this complete term, the decimal sign is not mentioned. If decimal is not mentioned, then all these trailing zeros are not significant. That means number of significant digits in it are one only. Number of significant digits are one. Only one digit is significant, which is 4. This is the significant digit. Next statement is trailing zeros are significant if decimal is present. If decimal is present at any point. For example, if it is mentioned as 40.00, then it has all the trailing zeros, 1, 2, 3, all trailing zeros are significant. That means total 4 significant figures are there. Are you getting my point? If decimal is there, then trailing zeros are significant. If decimal is not there, then trailing zeros are non-significant. There is one more point. They are significant if unit is mentioned. If unit is mentioned. Now let's take another example. This is the same thing, that is 4,000. There is no decimal. Now number of significant figures in it are 1. But if I mentioned there 4,000 meter, then it has 4 significant figures all these all these numbers are significant. I think every point till now is clear. I will repeat it very quickly. All non-zero digits are significant. Leading zeros are non-significant. Trap zeros are significant. Trailing zeros have three criteria. Trailing zeros have three criteria. Number one, they are non-significant if decimal is not present. If decimal is present, then they are significant. If unit is mentioned, then all trailing zeros are significant. I think till now everything is clear. One more thing, power of tens are non-significant. For example, if I say this is 2.3 into 10 raised to the power 25, how many significant figures are there? These are the non-significant digits. Only two significant figures are there. How many? Two significant figures are there. So now you need to solve few examples. Find the number of significant figures. Okay. How many significant figures are there? Everyone should answer quickly. In first question, how many significant figures are there? Sushant is saying two. Everyone should answer. Everyone. Okay, Chichuni has answered for all of the digits. Maybe na? Pridarshini. Okay, 2300. These are the trailing zeros. Only two significant figures are there. In this question, unit is mentioned. That means four significant figures. In this question, decimal is present. That means four significant figures. Very good. Now tell me about this one. Two. Very good. And this last one. This is trapped zero. So total three significant figures are there. I think it is clear. Very good, Pridarshini. Sushant. Now one more thing. After all such points, remember one more point. That point is numbers, or you can say pure numbers. Someone will ask, what is pure number? Have infinite significant figures. Infinite significant figures. You can choose the number of significant figures as per your requirement. I will explain you in detail about this after some time. Now the thing is, pure numbers have infinite significant figures. For example, if I say that area of the circle is pi r square, this pi is a pure number and it has infinite significant figures. And you know the value of pi, that is 3.14. I think there is a lot of numbers are there. So it has infinite significant figures, but we will choose number of significant figures in the pi as in the radius. We will choose the number of significant figures in the pi as per the radius. In the same way, if I talk about circumference, circumference is what? C. Can we denote circumference by C? I don't know what is the exact term we denote the circumference. Circumference is what? 2 pi r. In this question, r is the radius, pi is a pure number, and one more thing, this 2 is also a pure number. This 2 is not calculated. This 2 is not to be measured. This is the formula thing. And so in this equation, 2 is a pure number, and this 2 also have infinite significant figures. This is the very good line that I am saying, that if you are using a formula, then the quantity which can be measured has some finite number of significant figures. And we are going to calculate only those significant figures. But the 2, this is not to be measured. This 2 has infinite number of significant figures. I think this point is clear. Moving further. Now there comes a topic rounding off. So before rounding off, I will tell you one or two things. For example, there is a very popular question. Let's suppose it is mentioned that resistance, one resistance is 1.3265 ohm and another resistance R2 is 0.152 ohm. Find series combination. Find equivalent resistance of the series combination. You will definitely solve that R equivalent is equals to sum of these two quantities, that is 1.3265 and 0.152. Clear? Now, if you add this, it will become 5, 8, 7, 4, 1. I think I have added it correctly. So the answer is R equivalent is this one. Now the question is, how we should write this? How we should write this result? Okay, someone has answered, I think. Chichuni is saying 1.478 ohm. Okay. Now the thing is, the answer must have only those number of significant figures or that number of significant figures which the number has the number which has same which has least number of significant figures. Okay, I will repeat it again. Out of these two numbers, tell me the significant figures of each number. Each resistance, it has 1, 2, 3, 4, 5 significant figures. How many significant figures does this number have? How many significant figures does this number have? 152. How many significant figures are there? 3. Very good. It has 3 significant figures. So the result will have 3 significant figures only. Result should have 3 significant figures. That means 1, 4, and 7. And after this 7, the digits are to be removed. And the process of removing the digits is called rounding off. And the process of removing the digits is called rounding off. I think it is clear why we need rounding off, because the result must have those number of significant figures as contained by the number which has least significant figures. This sentence may be a little bit of confusing, but the example is clear. The least significant figures are 3. So answer must have 3 significant figures. So that means up to 7 we need to place it, and after that we need to remove it. So what are the rules of significant figures? So before that, you should understand one thing, that this 8 is the digit to be removed. This 8 is the digit to be removed. Now tell me one thing, if you know how to round off the things, then we can directly move to the next topic and solve a question. If you don't know, then I will explain it. So give me a hint of that. The digit to be removed is 8, and digit before it is called preceding digit. And digit after it is called digit followed or following digits. Clear this point. This digit is called following digit. Now I am assuming that you want this to be explained. That's why I will explain it. Now I think point is clear. So now in this slide, I will explain what are the rules of rounding off. Very simple rules. Digit to be removed. Now three possibilities are there. One possibility is, if digit to be removed if digit to be removed is greater than 5. Greater than 5. Are you understanding the meaning? If greater than 5 means which is greater than 5? Digit to be removed is greater than 5. Then increase, this is the symbol of increase, the preceding digit. PD means preceding digit by 1. For example, if I say there is a term 1.346 and you want only three significant figures in this number. You want only three significant figures, that means 1, 2, 3. That is 6 to be removed. The digit to be removed is greater than 5. Then increase the preceding number by 1. So answer will be 1.35. I think this point is clear. Second statement is if less than 5, which is less than 5, digit to be removed is less than 5, then preceding digit okay, we are coming for the third. This is the third point that we are coming. Preceding digit remains same. If it is less than 5, then preceding digit remains same. For example, in the same question, if it is mentioned that 1.345 and we need only, listen, less than 5, if I change it, it may be written as 343. And we need only this point. So what it will be? 1.34 is the answer. Now the third point. If it is equals to 5, then what will happen? There are few possibilities after that. So first possibility, I will tell you with the example. First possibility, if this 5 is followed by non-zero digits, non-zero digits, then what you should do? Increase the preceding digit by 1. Now, what does it mean? I will give you an example. This is the example of third case. For example, it is mentioned that 1.3451 and you need only three significant figures, yani up to this point you need. So digit to be removed is 5, which is followed by a non-zero digit. So you will increase the preceding digit by 1. So it will be 1.35. I think first point is clear. Second point in it, if there is no digit or 0 after 5. One thing is that 5 is followed by some non-zero digit. Second condition is that 5 is followed by either 0 or there is no digit. In that situation, what will happen? Now, there are two possibilities. What are the two possibilities? Preceding digit increases by 1 if it is odd and remains same if it is even. Now we need to check even and odd of the preceding digit. Now in this question, 5 is to be removed. After that, followed by no digit. Then if this 4 is even, if this preceding digit is even, then it will remain same. So answer is 1.34. If it is mentioned that 1.3350, digit to be removed is 5, and this 3 is odd, so it will increase by 1.34. Very good, Sushant. I think it is clear now. If these rules are clear, then we can move further. Very good. Tell me the answer of this question. Tell me the answer of this question. 15.8732, 5.89, 2, 3, 8, 9, 9. Is it clear? I have solved it correctly now. Now it has 1, 2, 3, 4, 5, 6, 6 significant figures, and this number has 3 significant figures. So our result should also have 3 significant figures. That means up to this point, we need to keep this. The digit to be removed is 3, which is less than 5. So answer will be 9.98. Clear? 9.98, which is B. Very good. I think someone has answered. Okay. Veena and Chijni has answered B. Very good. Moving further. Now errors. Take the screenshot. I think you know the definition of errors. We will solve a question so that we can understand how to calculate, how to solve the questions. The difference between true value and measured value is called error. There are two types of errors. Systematic error, you can read it out, take a screenshot. I will not waste any further time because there are 3 or 4 minutes left. Random errors, take the screenshot. Now there is a question. By question, we can understand the things. In an experiment, 4 quantities A, B, C, and D are measured with percentage error 1, 2, 3, and 4% respectively. So first of all, I will explain you how a percentage error can be written as. If they are talking about percentage error in A, so it can be mentioned as delta A over A into 100. This is the representation of percentage error. This is the representation of percentage error. Clear, I think. So that they are saying that P is related as A cube B square divided by CD. This is the topic of propagation of error. Whenever there are 2 or more quantities connected by a relation, then the result will have the propagation of errors. How we can write it as delta P over P. This is the error in the measurement of P. Will be the power is written before 3 delta A by A plus 2 times delta B by B plus delta C by C plus delta D by D. If you want to calculate percentage error, then you should multiply this term by 100 everywhere. It will become 100. I am multiplying the 100 in each term. 100, 100, 100. Now it will become, sorry. It will become percentage error in A, percentage error in B, percentage error in C, and percentage error in D. So this is called 3. Percentage error in A is what? 1% plus 2 into 2 plus 3 plus 4. Can you calculate this one? 4, 3, 7, 4, 11, 11 and 3, 14. That is 14%. Clear? There is one more question that you can answer. Answer this question very quickly. Sushant, Chichuni, Priyadarshini, Logesh. Answer this question. Veena. Kinetic energy is half m v square. You should solve it before me. Percentage error in K is delta K by K into 100 is equals to half has no error. Delta m by m into 100 plus 2 times delta v by v into 100. Now put the values. Delta m by m into 100, mass has a error 2%. So that is 2 plus 2 into speed has a error of 3%. That is 8%. Someone has answered before me. Veena has answered before me. Very good, Veena. That is 8%. So percentage error in the measurement of kinetic energy is 8%. Okay, listen again, listen. Chichuni, listen to me. The relation of kinetic energy is this one. This is the relation of kinetic energy. Now, if I say, what will be the total error? So you can write it as delta K by K. This is the error in the measurement of kinetic energy. It is directly proportional to m and directly proportional to v square. So the term, it has no power. So you just need to do one thing. It is equals to delta m by m. Why delta m by m? Because it has no power. The term which has power, you can write the power above or before delta v by v. This is the formula for the calculation of percentage error. What is it? If there is a relation between quantities, then the addition of the errors in respective quantities is the total error in the measurement. The addition in the percentage error of each quantity will be the total error. Then power is -2. If -2 is there, what are you saying? If no, there is no matter with that. If you are saying this is -2, then it has no significance. It has no, we have to add the errors. Errors are added. They are not subtracted. You cannot do it like -2. No. You will follow the same rule. Errors in the measurement are just added. In each of the measurement, errors are added. So we need to add them. Okay. I think this is clear. I think time is already up. One more thing that you should understand, you should know, because screw gauge is very important. I will not explain in a lot of detail. There are two things that you should learn here. Screw gauge, I think you have seen in your class 11th experiments classes. This is a main scale. I think it is mentioned here. This is the main scale, this one. And this is the circular scale or rotating scale. What we do, this screw is rotated and this gap or the thing which is the diameter or the thickness to be measured is placed in this gap. For example, we can place a small ball here, we can place a wire here. So this is the jaw. These are the jaws generally we can say. Now, there are two formulas. One is pitch. Pitch is what? The distance moved on the main scale in one revolution. When you rotate this screw gauge, then it moves one distance or some distance on the main scale. So in one revolution, the distance moved by it is called pitch. Distance moved by it in one revolution is called pitch. Now, what is the least count of the instrument? Least count of the instrument, you should remember the formula pitch over number of divisions in circular scale. The number of division in circular scale are given. Mostly they are either 50 or 100. They are either 50 or 100. Most of the times they are 50. Sometimes they are 100 as well. So least count is calculated as pitch over number of division in circular scale. Solve this one question. A screw gauge has least count of 0.01 mm and there are 50 divisions in its circular scale. The pitch of the screw gauge is, in 2020, this question was asked. So we know that least count is equals to pitch divided by number of divisions in circular scale. CS means circular scale. So we need to calculate pitch. Pitch is equals to least count. Least count is 0.01 mm into number of divisions are 50. So I think you can solve that. This is 0.5 mm. C. Veena is saying C. Sushant is also saying C. Very good. C is the correct answer. I think till now it is clear. So we will move to the next class. Tomorrow we will take another topic. I think this topic is clear. So bye everyone. I'm ending the session. Bye everyone.